in, in the years 2000 and 2006 respectively. He received his PhD degree from IKG Punjab Technical University Jalandhar in 2016 in the field of fractal antenna design. He is the member of IEEE ISTE Institution of Engineers and has been listed in Who's Who in the world. He has published 6060 journal papers and over 100 conference papers, along with 7 books and 10 plus book chapters. Dr. Dhaliwal has attended various conferences in India and abroad and has guided 5 PhDs and 70 MTech students. His main research areas include fractal antenna design, wearable antenna, 3D printed antenna, development of AI soft computing algorithms for antenna design, and digital filter design. Presently, he is the co-chief investigator in the MITY Government of India sponsored chip to startup project with worth 3.64 crore in the area of chip design. He has also completed several online courses on the topic like e-waste management and digital marketing. Dr. Dhaliwal is passionate about promoting the use of free open source ICT tools in education and has played a key role in obtaining NBA accreditation 3 times by implementing outcome-based education frameworks. Additionally, he has filed 1 patent showcasing his commitment to innovation and contributing to the field of technology. And recently, he has launched 1 lecture on the NPTEL as well in the language Punjabi. So it is one of the innovative work, and Dr. Dhaliwal is already always involved for some new creativity or some innovative kind of things. And we welcome you, sir, on this talk. And now, sir, you can proceed.
Thank you, Dr. Pankaj. So, thank you very much. Am I audible?
Yes, sir, you are audible.
Audible. Actually, I'm not able to switch on my camera. It is saying some setting problem. So kindly excuse me for that. I
No,
am trying, but it is
no
giving
issue,
like
sir.
this. I think you might be able to see the screen. It is showing like this.
Okay, sir, no issues.
Okay, so dear participants, welcome to this session. So first of all, I would like to start by thanking Dr. Pankaj, with whom I am having association of more than 20 years. So we were together at GNDC while I was serving there. So he's one of very good friend of mine. So I thank him for giving this opportunity to interact with you all. So let me show my first screen. Please let me know if my screen is visible to all.
Yes, sir, it is visible.
Visible and full screen, right?
Yes, sir, full screen is visible
Yeah.
and you are completely audible.
Thank you, Dr. Pankaj. So, dear participants, today I will describe an exciting and crucial application of machine learning, which is using supervised and unsupervised learning techniques to classify threats and detect anomalies. So, this is the outline of the this particular session. So, besides introduction and conclusion, I have divided the slides into 4 parts. So, first part is dedicated to the introduction, and then we'll be having this machine learning supervised and unsupervised parts. Then finally, this threat classification and anomaly detection. So these are the various parts of today's this session. So let me start with first why this topic is so important in today's context. So I'm basically starting with the introduction part. So we know that cybersecurity has become a top priority for governments, businesses, and individuals. From protecting personal information to safeguarding national infrastructure, the implications of cybersecurity are immense. A single breach can lead to very serious consequences, which may include like financial loss, data theft, and sometimes reputational damage also. Traditionally, organizations or institutions, they were relying on tools like firewalls or intrusion detection systems or some kind of antivirus softwares to secure their systems. Although these tools are effective to a degree, but the issue is that these tools basically rely on predefined rules or some kind of signature-based detection. So when we are talking of now newly uh, visible threats, so this approach struggles basically with this new and evolving threats, such threats like zero-day vulnerabilities or polymorphic malware. So basically where there are no prior signatures exist. So in such scenario, machine learning is a powerful tool. So through its ability to learn from data, this machine learning offers a revolutionary approach to threat detection and prevention. So unlike the traditional tools, it does not rely solely on predefined rules. Instead, it learns patterns from data to detect anomalies and classify potential threats effectively. So if we see this slide, in the first point, you can see that according to a particular survey, it is expected that the cyber crime will cost approximately $10 trillion or even will exceed this value by the end of 2025. So we can see that this figure highlights the important financial impact of cyber attacks, so which includes data breaches or some kinds of ransomware incidents or system downtimes. So these are not just statistics. So basically, these are the real world consequences for various kinds of organizations like businesses, governments, or individuals. So today, there are advanced threats or the most sophisticated threats than in the past. So today, attackers are leveraging techniques like zero-day exploits or polymorphic malware, advanced persistent threats. So basically, zero-day exploit means these take advantage of vulnerabilities that have not yet been plugged or patched, and these are discovered by the attackers. And polymorphic malware, so basically refers to the threats that constantly change their code to evade detection by the signature-based tools. Similarly, advanced persistent threats, APTs. So these are the long-term targeted attacks aimed at gaining continuous access to some systems. So that traditional security measures, such as which we are using right now, firewalls or some signature-based antivirus software, so these are not effective against such advanced these threats, because they basically rely on known pattern or predetermined rules. So that is the major limitation of the traditional tools. Like if you talk of zero-day exploit, so it has no prior signature, so it will be difficult to detect it by the most maybe traditional antivirus solution. Similarly, polymorphic malware, if we talk of this, so it can morph its structure, so it can bypass static signature detection kind of requirement. So these gaps create the need for more adaptive, intelligent approaches like machine learning. So machine learning has many advantages. Main advantage is that unlike the static rules, machine learning models adapt to new and evolving pattern in data. So it basically learns from data. It is able to detect anomalies based on behavior, not just on predefined rules. Machine learning also offers proactive solutions by identifying potential threats before they materialize. So in machine learning, the basically expectation is that machine learning does not just react, it anticipates and adapts and makes it an indispensable tool in today's security scenario. So nowadays, if we talk of the scale of data, then we can easily get this idea from the working of the organizations that many of the organizations generate and process a large amount of information. So that amount of information or amount of data, so it represents both an opportunity as well as a challenge for threat detection. We have system logs, we have network traffic, so user behavior, transaction records. So the volume of data is generated daily in different forms. And so in some large organizations, we have, we can say, data of the size of petabytes of data every day. So we have this data from different sources. Some of those are connected devices, some are from cloud services, or some are from user interactions. So it is so when we have this large amount of data, so question is not just how to store this data, but how to analyze it effectively to uncover the meaningful insights. So that is the problem. So processing such large amount of data is a basically problem. So there are several challenges based on the nature of the data. So data can be unstructured data or distributed data. So data like log files or user activity records. So there is no particular defined predefined format for this kind of data. So it makes it difficult to process this kind of an unstructured data. And information is many times scattered across multiple systems or multiple devices or locations, so which again complicates the analysis, centralized analysis of data. And cybersecurity requires real-time processing as data flows in continuously in many applications. So delays in analysis can leave organizations exposed to threats. So that is another challenge which is related to the processing of data. So if we consider these challenges, then we can easily come to the conclusion that manual or traditional methods of analysis are no longer sufficient, or they will be effective. So we need some kind of AI tools, machine learning tools, which provides robust solutions to such complexities. So these ML models can process large amounts of data quickly, and they can identify patterns that would take human analysts days or weeks to uncover. Similarly, techniques like natural language processing or clustering algorithms, so they can sense messy or unstructured data. And cloud-based machine learning models can analyze data from multiple sources, and they can ensure that there is no overlooking in any kind of device. So let's consider one example of network traffic. Imagine that we have a network system, which generates terabytes of log data daily. Then in this data, there can be some kind of irregularities which can be hidden in the data, like sudden spike in traffic from a particular IP address. So that can be a indication of a potential breach, but it can be hidden in large amount of data. But if we have some kind of anomaly detection algorithm, then that algorithm can scan this kind of data in real time, and it can flag suspicious activity, and it can warn the network administrator about the action. So these cyber threats are basically not static. They operate at very high speed. We can say very lightning speed, and we need to respond in real time, which is very difficult if we talk of traditional tools or manual analysis. Otherwise, if we are not able to respond in real time, then we'll be basically victim of some kind of attack, or there will be some say consequences related to this. So timing is everything. Speed is very critical in cyber security or securing these systems. If the attackers get a smallest window of opportunity, then they are ready to cause the harm to our systems. So there can be data breaches. Sensitive information like customer data or intellectual property can be basically copied within minutes, within moments, within seconds, if the chance is obtained by the attackers. There are different kinds of ransomware attacks. So they encrypt files rapidly. So they log the user accounts or the user systems, and they basically force for some kind of money, or basically results in a crisis kind of situation. Then there are denial of service attacks, which can basically make websites or services inaccessible within seconds, and it will disrupt operations of the organizations. So in such cases, the time is very important. So the speed at which we are detecting the threats, so that is very important. So if we are able to detect the threats in the real time, so then it will be easy to basically manage that threat. Then there are certain challenges which are associated with this delayed detection. So if the breach goes unnoticed, say for long time, say for hours or days, then it can result in significant data loss, and or it can result in operational downtime. Similarly, if the longer a threat remains active, the more expensive it becomes to contain and recover from the attack. And also the news of delayed response can damage customer trust and harm an organization's public image. Say there is some kind of organization which is having some, say, our sensitive data recorded on this servers. So if the organization is not able to detect the threats in real time or in small times, then we can think that we'll not able be trusting that organization to store our important information. So all this makes it basically very important that organizations should be proactive, and they should have real-time solutions. So machine learning can help organizations in implementing real-time solutions also, real-time detections also. So under this machine learning, we'll talk of supervised as well as unsupervised learning. So in supervised learning models, these models are trained on historical threat data, and they are capable of identifying similar threats in real time. For example, a network monitoring system is trained on labeled data, and then it can instantly classify incoming traffic as normal or malicious. Similarly, say we talk of email security systems. So these systems use supervised models to detect and block phishing attempts as they arrive in inbox. So we all know that in our email accounts, so we have different folders. So some kind of mails are not shown in our inboxes. Similarly, there are unsupervised learning algorithms. So unsupervised learning takes this a step further by identifying unknown threats based on deviation from normal pattern. For example, if we are having an anomaly detection model, so it can monitor network activity and it can flag unusual spikes in traffic or irregular login attempts without needing predefined labels. So this kind of strength makes unsupervised learning particularly valuable for detecting several kinds of threats like zero-day exploits or evolving attack strategies. Then there are several machine learning algorithms which are specifically designed to handle the demands of real-time analysis. So there are algorithms like streaming k-means, isolation forest, RNN, recurrent neural networks. So these real-time detection systems are used in several practical applications. To name a few, fraud detection in banking, IoT security, critical infrastructure protection. So basically, the major benefits of real-time detection include reduced impact. So if threats are neutralized before they can cause significant harm, so then obviously the impact of the threat will be reduced. Cost saving is another benefit of real-time detection, that early interventions minimizes recovery and downtime costs. Similarly, increased trust is another benefit of real-time detection. Organizations that can demonstrate rapid response capabilities, so they are able to build greater trust with their stakeholders. So machine learning techniques are not only important to the cybersecurity, they are basically extending their presence far beyond the cybersecurity. Like financial services. So machine learning helps financial institutions detect frauds by analyzing transaction patterns. So classification algorithms can identify unusual spending, while anomaly detection flags transactions that deviate from normal behavior, helping prevent financial losses. So this is one area where machine learning algorithms are helpful. Then healthcare is the another area. So machine learning can identify ransomware attacks in real time. So by monitoring system behavior, anomaly detection can pinpoint encrypted files and alert security teams, and it will result in minimizing disruption to maybe hospital operations. So if we're talking of healthcare organization. Similarly, in case of industrial IoT, the machine learning monitors device behavior, so it detects irregularities that could signal sabotage. And this proactive monitoring helps costly damage and ensures the safety and efficiency of industrial operations. Similarly, in energy sectors, say smart grid monitoring. So in such cases, machine learning also enhances this smart grid monitoring. So anomaly detection identifies faults or cyber attacks early. So it ensures a reliable and uninterrupted energy supply by enabling quick response to issues. So machine learning is just not enhancing the security across various sectors, but it is basically helping in achieving high operational efficiency and resilience. Similarly, machine learning and AI are key players in the ongoing cybersecurity arms race. So this AI enhances cyber attacks like deepfake phishing, where attackers use AI-generated media to impersonate interested individuals. So like we have many times seen that even in India, our popular leaders are sometimes shown in deepfake videos. And AI-driven bots are there which automate intrusions. So these are bots learn from defenses, and these find new ways to bypass them. But if the machine learning models, we use the machine learning models, so these models adapt quickly to new threats. So they learn from emerging attack patterns with minimal manual interventions. So it allows defense to stay updated without human updates. So a combination of supervised and unsupervised learning offers proactive defense. Supervised learning handles known threats. Supervised learning handles known threats, while unsupervised learning can detect new and unknown threats. So this combination will ensure continuous protection. So the adaptability and proactive defense of machine learning. So these are essential to keep basically pace with the growing complexity of cyber threats or cyber arms race. So now let's talk about the cost effectiveness and scalability. Machine learning basically offers significant advantages in terms of cost effectiveness and scalability also. Because machine learning is highly scalable, so it means that it can efficiently process a large amount of data without requiring proportional increase in resources. So whether it's a network traffic data or system logs, so machine learning models can handle large data sets, making them ideal for organization with expanding digital footprints. And with machine learning, so we can get reducing infrastructure and personal needs. By automating the threat detection and response, machine learning reduces the need for expensive infrastructure and human interventions. So traditional our security systems, they often rely on extensive human oversight and costly hardware. But if we use machine learning, then the system evolves with minimal intervention, and this basically lowers the long-term operational costs. So these machine learning algorithms are ideal for growth because they support increasing cybersecurity needs. So as the organizations grow, so their security needs also increase. So if we use machine learning, then it supports this growth by, because these are adaptable and efficient solutions. So these machine learning solutions can scale within an organization's expanding data and security demands. So this will basically ensure that cybersecurity remains reliable, robust as the organizations grow and they face more complex challenges. So we can say that machine learning provides a cost-effective, scalable solution to meet the growing demands of modern cybersecurity systems. So now this basic introduction of this particular importance of this topic. So now let's move to the second part, so which is basically related to the supervised learning. So let's start with this brief introduction to machine learning, although I'm sure that most of the participants will be already knowing this. So just to recall briefly, so when we say machine learning, so at its core, so basically machine learning is a branch of AI that enables systems to automatically learn and make decisions based on data. So these ML algorithms use data to identify patterns, and then these algorithms make predictions or decisions. So this learning process helps the system to improve its accuracy over time, and as it gains more experience from new data. So in other words, we can say that machine learning is about teaching a computer or a machine to recognize patterns, make predictions, and improve itself through experience, just like humans learn from experiences. For example, we can consider a spam detection in emails. So a system trained with thousands of labeled emails, whether those mails are spam or not spam, then it learns to recognize the patterns, maybe certain words or phrases that differentiate spam and the unspam emails. So over the time, the system improves as it encounters more data or more emails. So sometimes we find that wrongly legitimate email is classified as spam, but once we inform our email server that it is not spam, then next time we experience that email is not sent to spam. So that kind of learning is there. And this machine learning has wide-ranging applications across different fields. So it is not limited to just only one sector, but this machine learning is transforming multiple areas, such as we can say cybersecurity, as just we have seen, healthcare, finance, or retail. Even autonomous vehicles is the basically new critical application where machine learning is helping self-driving cars to interpret sensor data and to identify object and to make decisions in real time. So the power of machine learning lies in its ability to adapt and improve, but no matter in which field we are applying the machine learning. So one of the key advantage of the machine learning is that it enables the systems to learn from data and continuously improve without human intervention. So this basic learning process involves few steps like training, then model evaluation and continuous improvement. So in the training phase, machine learning algorithm is provided with labeled data. Then algorithm learns from the relationships between inputs and outputs, and it adjusts its internal parameters to minimize prediction errors. And after training, the model is evaluated using new and unseen data to assess how well it generalizes and makes accurate predictions. And as more data becomes available with time, so the system can be retrained and it can allow it to improve over time. So this kind of retraining is especially valuable in dynamic environments where patterns change frequently, such as application of fraud detection or customer behavior analysis. So now let's briefly go through this supervised learning. So you may be already knowing that supervised learning is one of the foundational types of machine learning where models learn from labeled data. So this is a type of learning which is most commonly used for classification and regression tasks. So supervised learning can be defined as a machine learning technique where the model is trained on labeled data. So but it means that for every input data point, the corresponding correct output is already known. And model's task is to learn the relationship between the inputs, which are also sometimes called features, and the corresponding outputs, which are also known as labels, so that it can make accurate predictions on new and unseen data having the same relationship. For example, if we consider building a model that predicts whether a student passes or fails based on their study hours and test scores. So in the training data, and then each entry will contain the features like the study hours and the test scores and the label pass or fail. So the algorithm will learn the patterns from this data so that it can predict whether the future students will pass or fail based on their study hours or test scores, right? So there are a few key concepts in supervised learning, so which includes training phase and prediction phase. So as I just described over the previous slide, that in this training phase, the algorithm is fed with labeled data. So it analyzes this data and learns patterns or relationships between the input features and the corresponding labels. So the goal in this training phase is to learn a model that minimizes the error between the predicted outputs and actual labels in the training set. For example, if we are predicting, say, house prices based on features like size and location, the model will learn how these features correlate with house prices in training data. Then comes the prediction phase. So after the model has been trained, it is ready to make predictions on new and unseen data. So the input features for new data are applied to the trained model, and the model predicts the corresponding output, whether it is a category like in case of classification application, or a continuous value in case of regression application. For example, if you consider again same example of predicting the house prices, so we can predict the price of a new house based on its size and location, based on the trained model. So if we talk of use cases of supervised learning, so it is particularly useful in scenarios or applications where historical data with known outcomes is available. This enables the model to learn from past experiences and generalize that learning to new and unseen data. So this supervised learning is widely used in applications where we have to classify classification applications. So where the goal is basically to assign input data into one of the several predefined categories. So for example, classifying email as spam or not spam, or diagnosing diseases based on medical records. So these are some examples of classification. Then there are regression applications where the goal is to predict a continuous value. For example, predicting stock prices based on historical data, or predicting real estate prices based on property features. So we can say that supervised learning involves training a model on labeled data where the correct output is known, and using that model to predict outcomes for new data. So when the historical data is available, this kind of model is particularly useful, and it can learn patterns that can be applied to future or unseen data. So now let's go through some common algorithms in supervised learning. So there are some of the algorithms which are very important, as these algorithms help in making predictions based on labeled data, and each algorithm has its own strengths and applications. So let's start with the first, decision trees. So a decision tree is a flowchart like structure where each internal node represents a decision based on the value of a particular feature. Each branch represents the outcome of that decision, and each leaf node represents a classification level or a regression outcome. So basically, a decision tree splits the dataset into subsets based on the most significant feature at each node. And this process continues until a stopping criteria is met, like a maximum depth or minimum data points per leaf. And the goal is to create homogeneous subsets where data points in each subset are as similar as possible. We can consider the example of building a model to decide whether a loan application should be approved. The decision tree might start with a node asking what is the applicant's credit score. If the credit score is above a threshold, then the tree might branch towards approval. Otherwise, it might towards the rejection. And the advantage of this decision tree algorithm is basically these are easy to understand and interpret, and these can easily handle both categorical and numerical data. And nonlinear relationships between features don't need to be explicitly modeled in case of decision trees. But the disadvantages of this decision trees algorithm include, so these are prone to overfitting, especially with the complex trees, and these can be sometimes unstable, meaning small changes in data might result in a completely different tree. Okay, now let's see the second very commonly used this model, which is support vector machine. So this SVM is a powerful algorithm which is primarily used to for the classification task, but it can also be applied for the regression problems. So this works by finding a hyperplane that best separates data points into different classes. The goal is to maximize the margin, which is the distance between the hyperplane and the closest data points from either class, and it is known as support vector, and hence the name support vector machines. So a larger margin typically results in better generalization to unseen data. So for this SVM algorithm, we can consider the example of classifying emails and spam or not spam. So the SVM algorithm would find that the hyperplane that best divides the feature space based on the characteristics like frequency of certain words, or so that the spam emails are on one side of the hyperplane and non-spam emails are on the other side of this particular hyperplane. So the advantages of this SVM includes that this algorithm is effective in high dimensional spaces. For example, text classification. It can handle both linear as well as with non-linear data if we are having right kernel function associated with the algorithm. At the same time, disadvantages of this SVM include these are computationally expensive, especially when we are dealing with large data sets. And the choice of the kernel and regularization parameters can greatly influence the performance of SVM algorithm. Next very commonly used algorithm in supervised learning is the neural networks, sometimes called artificial neural networks also. So as we know that neural networks or the artificial neural networks are inspired by the way biological neurons work and are composed of layers of interconnected nodes, which are called neurons. And these are very powerful for various tasks like image recognition, speech processing, and complex data prediction. In general, neural network consists of three layers. So one is called three types of layers. So one type is called input layer. Then we have hidden layers and output layer. So the input layer see the input features. Then the hidden layer perform computations and learn complex patterns in the data. And in the output layer, it produces the final predictions or classification. So output is obtained from these output layers. And during the training process, the model adjusts the weights of connections between neurons using a method which is called commonly called backpropagation or some kind of other algorithm. And the goal is to minimize the error between predicted and actual values. For example, if we consider handwritten digit recognition, for example, we want to identify whether an image contains a digit 3 or a digit 7. Then the neural network processes the pixel values, learns patterns in the data through hidden layers, and outputs a prediction of the digit in the final layer. The advantages of this particular model include that they can model highly complex and non-linear relationships in data. They are highly effective for tasks like image and speech recognition. But there are some of the limitations. And the first limitation is that these require sufficient or large data sets and substantial computational resources during the training phase. And many times it is difficult to interpret and explain the decisions made by the network, leading to concerns about model transparency. So that is another issue with these neural networks. Now, next algorithm is the algorithm which is known as the linear regression. So this is one of the simplest and most widely used algorithm, especially for regression tasks where we predict continuous values. So in classification, we basically produce output as one of several categories. But in regression tasks, output is continuous values. So this linear regression basically tries to model the relationship between the dependent variable, basically output, and one or more independent variables, which we name as features, by fitting a linear equation to the observed data. The equation of a straight line is generally used to predict the output based on the inputs. So this model learns the coefficients or weights of the features during the training phase by minimizing the difference between the predicted and the actual values. Suppose we want to predict house price based on features like size, location, and number of rooms. Then the model learns the relationship between these features and the price, and then uses that to predict the price of a new house based on its features. The advantages of this particular linear regression include simple and interpretable. It works well when the relationship between the variables is approximately linear. But if as it takes a linear relationship, so it might not hold in many real world situations. So that may be then counted as one of the disadvantage of this model. And this model is sensitive to outliers. And so if there are outliers in the training data, so then they can distort the model. So we have talked of four models: decision trees, SVM, neural networks, and linear regression. So all models have their own strengths, and these are suited for different types of problems. And similarly, each model is having some its own limitations, which we need to keep in mind while selecting a model. So if we are able to understand these algorithms properly, then we can choose the best one depending upon the problem which we are trying to solve, depending upon the nature of data as well as the required transparency in the model. So we can consider all these factors while deciding. Okay, now let's see one example of this email spam detection. So the goal is to classify emails as either spam or not spam. So not spam, we can call it as ham. So using the supervised learning approach, so it involves, we can see the four steps. First is training data, then features, then learning process, and prediction. So we want to automatically classify emails into one of two categories, spam or ham. So spam refers to the not desirable or harmful messages like phishing attempts or some promotional offers. And ham we call as the desired mails. So the challenge is to develop a system that can automatically identify these categories without human interventions. So in the training data, we need a data set of labeled emails. So each email in this data set is tagged as either spam or ham. So this labeled data set serves as our ground truth, meaning that the labels guide the learning process. For example, we might have thousands of emails where each one is marked as either spam or ham. So this data set is crucial because in supervised learning, the model learns from this data to understand the relationship between the features of an email and its corresponding label. Then once we have this data set, we extract features from email content that will help the model differentiate between spam and ham, and some common features which are basically extracted. So these includes presence of certain keywords like a free, win, price. So in many of the spam emails, so we have such keywords, and there are sender informations like emails from unknown or suspicious senders may be flagged as spam. And frequency of certain phrases can be another feature, like phrases like urgent action required or click here. So these may be associated with some kind of phishing attempts. So these features allow the model to build a profile of what makes an email spam or ham. So by using these features, the model learns patterns in the data that will later help it make predictions on new or unseen emails. So once we have the training data and we have extracted the features, the next step is model training. So which is basically labeled here as learning process. So in this phase, we choose a learning algorithm that will learn the relationship between the input features and the labels. Labels here in this example include spam or ham. So we have seen several commonly used algorithms like decision trees, support vector machines, or neural networks. So we can use select one algorithm which will be uh, able to make predictions after the training. So during the training process, the algorithm works to find patterns in the data, then it adjusts its internal parameters to minimize the error in predicting the label based on the input features. So for example, a model will learn that emails contain certain words like price or click here. And if such words are there, then they may be classified as spam. So this pattern is encoded in the model, so it can classify future emails correctly. Once we have gone through the learning process, then there is the prediction step. So once the model is trained, we can use this to predict the label for new and incoming emails. So the model applies the learn patterns to classify each new email as either spam or ham. For example, say we have an email with a subject line, say you have won a free iPhone, and the body content uh, contains click here to claim your prize. So then most likely it will be classified as spam if we have trained the model to classify the emails containing words as prize or click here as spam emails. On the other hand, if there is an email about a meeting request from a known sender, then it would be classified as ham. So there are certain challenges when we talk of such email spam detection or such models. So one of the challenges in spam detection is the variety of spam types. So spam can come in many forms, like it can be phishing emails, or it can be some kind of undesirable promotional offers. It can be malicious attachments, like fake lottery claims kind of emails. So spammers are basically continuously evolving their tactics. So the model also needs to adapt to these changes. So like spam email might be using some more sophisticated language. So it can be changing tactics or disguising the true intent. So then model must be flexible to recognize these new patterns without relying on outdated indicators. Another challenge is the feature selection. So not all email attributes are equally important for distinguishing between spam and ham. For example, the presence of certain words might be a strong indicator, while other features like the email length or time of day might not contribute much. So selecting the right features is critical. And as irrelevant features can introduce noise into the model, and these irrelevant features will reduce the basically accuracy of the model. So the effective feature selection process ensures that model uses the most informative features for making its predictions. So with this, now let's go through advantages of this supervised learning. The primary advantage of supervised learning is its ability to deliver highly accurate predictions, provided it is trained on a large and well-labeled data set. So the supervised learning algorithms like decision trees, SVMs, or neural networks, so they learn specific patterns and relationships between input features and the corresponding output labels during the training phase. So this enables them to make precise predictions on unseen data, like we have seen the example of spam detection. So the accuracy of the model improves with as the data set grows in size and diversity. So basically, it highlights the importance of quality data in supervised learning. Another advantage of supervised learning is ease of understanding and transparent relationships. So the clear and interpretable nature of supervised learning models makes these models simpler ones. Because supervised learning focuses on mapping specific inputs to the outputs. So this clear relationship makes it easier to understand the why a particular input is classified or is predicted like a particular output. And models like decision trees, these provide a visual flow of decision making. So it helps users trace how the model reached a particular conclusion. Similarly, this transparency also helps in non-technical stakeholders, which may be the end users, to trust the model outputs. And wide application of supervised learning is another advantage. So this supervised learning can be applied to large number of practical problems, which may include like classification tasks, where the goal is to categorize data into predefined labels. For example, spam detection example we have considered, image recognition or disease diagnosis. Similarly, there can be regression tasks where the goal is to predict the continuous outcomes such as house prices or stock market prices, or there can be applications like pattern recognition where identifying relationships or trends within the data, such as customer behavior or fraud detection in finance, so that so such kind of applications. So machine learning can be used in various different fields. So it has strength in different fields. Okay, now let's go through some of the limitations of supervised learning. So dependence on labeled data. So in the earlier slide. So is there any query? So I am hearing some kind of audio. So I request the participants, if there is no query, kindly mute your mics. So the first limitation you can see is related to the labeled data. So in the previous slide, we have said that this data is also one strength of this particular model, supervised learning models. But this can be a limitation also, because labeling data requires human effort, especially in complex tasks like medical diagnosis or image recognition. So it will not be very easy to generate large amount of data which is required to train the model, or if it is possible, sometimes it can be very expensive or time consuming. So if the this particular data is sufficient data is not available, then it can limit the scope of supervised learning, making it less feasible for tasks where labels are rare or costly to obtain. For example, if we consider the fraud detection area, then collecting enough labeled instances of this fraud transactions can be a challenging task, because fraud is a relatively rare event. So it can be difficult to train a supervised learning model for such applications. Then another limitation of supervised learning is overfitting. So this overfitting occurs when the model learns the training data too well. So it captures noise or irrelevant details instead of general patterns. So when a model is overly complex or trained on insufficient diverse data, it might memorize specific example rather than generalizing. So this is called overfitting. So this overfitted models perform well on trained data sets, but they do not perform good with new or unseen data. And so they reduce their real world utility if we talk of the overfitted models. Similarly, scalability issues can be there. So it can be a challenge. The supervised learning can struggle with scalability, especially when working with large or complex data sets. Because training a model on massive data sets requires substantial computational resources, including memory, processing power, and storage. And if the model is not properly trained, then it model can make supervised learning basically less reliable. If this particular scalability issue makes supervised learning sometimes computationally expensive and slow, when particularly organizations are not having, say, high-end these computational resources. For example, if we talk of video analysis or real-time cybersecurity monitoring, so then we need some advanced or very computationally efficient hardware and algorithms, so that we can have reliable outputs. So if we talk of scalability, then use of parallel processing or cloud computing, so they can help to address the scalability challenges in case of the supervised learning. Okay, now let's move to our third part, which is about unsupervised learning. This, unsupervised learning is a type of machine learning where the model works without labeled data. So instead of being guided by specific answers, the model is tasked with analyzing input data to uncover patterns or relationships or structures. So in unsupervised learning, it learns independently, so identifying grouping or trends that are not basically explicitly defined in the data. For example, if we consider that we want to organize our bookshelf, so we may not have some then predefined categories, but we may be interested in organizing, say, books by the size or color or based on genre. So we can observe such patterns, and then we can classify or categorize our books, and we can organize our bookshelves accordingly. So the goal of unsupervised learning is not prediction, but discovery and finding hidden insights that are not immediately obvious. So that is the major goal of this unsupervised learning algorithms. This unsupervised learning plays a crucial role in several machine learning applications. And why this is important? Because many times labeled data is not available, or if it is available, it is costly. And many times discovering unknown pattern is the main goal of designing the algorithm. So this unsupervised learning is different from supervised learning, as it has no labeled outcomes. So instead, it uncovers hidden structures, such as grouping emails based on topic or tones, so without knowing what the group represents. So that kind of scenario can be more suitable for unsupervised learning. Unsupervised learning is finding applications in wide range of fields, like cybersecurity field, so detecting unusual server activity or new types of malware without prior examples. Healthcare, where we want to group, say, patients with similar symptoms or similar medical histories. Or finance, where we want to identify, say, unusual transaction patterns. So such areas are suitable for unsupervised learning algorithms. Now let's see key characteristics of unsupervised learning. So as I just described over previous slide, that one of the important characteristic of unsupervised learning is that its reliance on unlabeled data. So labeled data is not required. So there are no predefined outcomes or categories to guide the process. So what it means, so basically the model only has raw input data, So it identifies structures and patterns in this data without the benefit of any prior knowledge. For example, in say if we take the application of customer segmentation, where we have data on customer behavior, for example, purchase history, browsing habits, or preferences, but we are not having predefined labels like frequent buyer or one-time shopper. Then this model can group customers based on similarities in their data. So such kind of applications can be there for unsupervised learning. And another key characteristic of unsupervised learning is focus on patterns. So and this unsupervised learning is based on patterns. It does not predict. So instead, it basically reveals hidden relationships or clusters, or even simplifies complex data sets. So clustering means grouping similar data points, like categorizing news articles by topic, or there can be associations, finding relationships such as customers who buy a specific product often more times than other customers, or dimensionality reduction means simplifying large data sets while retaining the most important information for easier visualization or processing. Another important characteristic of this unsupervised learning is the autonomous learning. So this unsupervised learning operates independently. In supervised learning, we need to provide explicit instructions to label data. So, but in unsupervised learning case, it is more exploratory. So it is able to explore the more. So basically, model is not told what to find. So it uncovers insights based on the patterns and structures within the data itself. So these characteristics make unsupervised learning a powerful tool for uncovering insights in large and complex data sets. So by focusing on patterns and learning autonomously, so it opens doors to discovering the unknown, which is a critical ability in today's data-driven world. Okay, now let's go through common algorithms in supervised learning. So first, let's go through this k-means clustering algorithm. So k-means clustering algorithm is one of the most commonly used algorithm in unsupervised learning. So it helps basically in organizing data into meaningful groups or clusters, even when we have no prior labels or categories. Basically, k-means clustering groups data into k distinct clusters. Each cluster contains data points that are similar based on their features, such as maybe numerical value or pattern or some other type of feature like text content. So this algorithm works by ensuring that data points within the same cluster are close to each other as possible. And clusters themselves are as distinct and far apart as possible. So these are the two basically guiding points for this algorithm. So let's see how it works. So initially, this algorithm randomly selects k points in data space as cluster centroids. Then these centroids basically act as initial points for grouping data, or initial center points. Then in the second step, every data point is assigned to its nearest center. The distance metric, generally Euclidean distance, determines the closeness. Then once all points are assigned, the centroids are recalculated. The new centroid becomes the mean of all points in its cluster. So this process of reassigning points and recalculating centroids repeats until convergence, meaning the centroids no longer move significantly or the data points stay in their cluster. So at that point, this algorithm will stop. So if we talk of use cases of this k-means clustering algorithm, then we can consider example of this customer segmentation. So imagine that a retail company wants to understand its customers better using K-means clustering. One cluster might represent customers who frequently buy luxury items. Another might represent occasional buyers of essentials. Then there can be another cluster in which we can group customers who are price sensitive and only shop during sales. So this kind of segmentation allows businesses to tailor marketing strategies or personalize customer experience and optimize basically their inventory management. And we can consider again the same example of organizing books in a library or on our bookshelf. So when there is no genre with predefined, so we can examine the patterns like similar topics or language or themes. Then we can form groups of the books, and then we can basically store similar books in say nearby places. So this K-means clustering algorithm showcases the power of unsupervised learning by turning raw data into actionable insights. So identifying patterns or simplifying complex data sets. So these are the two major characteristics of this working of this this algorithm, K-means algorithm. Then the second commonly used algorithm in unsupervised learning is the PCA, Principal Component Analysis. This principal component analysis or PCA offers a solution by simplifying data while retaining its most important aspects. So if we talk of the working of this PCA, then we can consider the simplification of high dimensional data. So PCA will help in sensing of high dimensional data by reducing its complexity. So it can identify and preserve the most important features that contribute to the variability in the data. And then PCA transform the data set into a new coordinate system called principal components. So these components are ordered such that the first few captures the maximum variability or information present in the data. So this PCA does not basically discard informations recklessly, or we can say without consideration. Basically, it ensures that retained components explain the majority of data's variability. So how it works? So to understand that, we can go through these 2 points shown under this heading, how it works. So the algorithm starts by analyzing the variance in the data set. It identifies directions or axes along which the data varies the most. Then these directions become the principal components. Once these components are identified, the data is projected onto them. So this effectively reduces the number of dimensions while retaining the underlying structure and pattern. Then this transformed data set is smaller in size, yet it retains the essence of the original data, so it makes it easier to analyze or visualize. So we can consider this use case of visualization and pre-processing to understand this principal component analysis algorithm. So imagine that we are working with a data set of genomic sequences that has, say, 100 features. So we want to analyze or visualize this data set, but it will be analyzing such 100 features is very difficult or nearly impossible. So PCA can reduce the complexity, allowing us to visualize the data in 2 or 3 dimensions through a scatter plot. So that can be advantage of this algorithm. So also PCA can make subsequent machine learning tasks more efficient by focusing only on most significant features, and so it reduces the computational overhead. So we can consider this PCA as compression example. So we can think of PCA as compressing a large detailed photograph into smaller file size. So the compressed image will retain most important details, which will allow us to basically uh, learn the details about the this image without maybe the excess data. So this BCA can keep the more important information in the image, and it can discard the redundant information. So that way, it can help in reducing the size while keeping the most important information intact. Now, the next algorithm, which is very important in unsupervised learning, is the autoencoders. So these are basically autoencoders are applications of neural networks that allow machines to learn efficient data representation. So by compressing or reconstructing data, so these autoencoders offer a powerful way to uncover hidden patterns and detect anomalies. So these autoencoders are type of neural networks which are designed specifically for unsupervised learning. So their primary purpose is to learn compact, uh, efficient representations of data. So they work by compressing the input data into smaller and encoded format and then reconstructing it to resemble the original. So the entire process trains the model to focus on most critical features of data. So we can consider think of autoencoders as filters, so which can say we consider as removing noise or irrelevant details, leaving only the core important features of data. So they work in two phases. First phase is called encoding phase. So in the encoding phase, the input data is passed through layers of the neural network to compress it into smaller encoded representation. Then this compressed form contains the most significant features of data. Then in the decoding phase, the encoded representation is expanded back to reconstruct the original input. The goal is to make the reconstructed data as close to the original as possible. So then comes the learning process. The autoencoder is trained to minimize the reconstruction error, which is the difference between the original input and the reconstructed version. So over time, the model learns to encode the most important aspects of data efficiently. So we can consider this anomaly detection as use case for the autoencoders. So autoencoders are highly effective in detecting anomalies. For example, in network traffic monitoring, an autoencoder can be trained on normal traffic pattern. So it learns to reconstruct typical behavior with high accuracy. So when the network encounters unusual or unfamiliar pattern, then it basically struggles to reconstruct them accurately. So this leads to a spike in reconstruction error, so which signals a potential anomaly. So this way, this anomaly can be detected. So this ability to differentiate between normal and abnormal patterns makes autoencoders very important for tasks like fraud detection, system monitoring, and cybersecurity. So we can consider uh, trying to describe a detailed painting in just a few words. Then description must capture the painting's essence, its primary colors or key elements or overall feel. So now we can think of this using those few words to recreate the painting. So autoencoders basically face the similar challenge. So they must compress complex data into a concise representation and then reconstruct it with minimal loss of detail. So autoencoders showcase the potential for neural networks in understanding and processing data. So by learning to compress and reconstruct, they enable efficient representation, noise reduction, and anomaly detection, so which makes them important tools in machine learning domain. So we can consider this example of detecting unusual patterns in server traffic as one basically method to learn this about unsupervised learning. So detecting unusual patterns is a very crucial task in nowadays security systems. Imagine that a company is managing an extensive network of servers that handle everything from, say, user requests to internal operations. So in such applications, most of the traffic will follow predictable pattern. Any abnormal activity such as cyber attacks or some kind of sudden surge, so it will disrupt the operation or it will signal a potential basically breach. So the company needs to identify these anomalies as early as possible, even if they don't have any prior example of any normal behavior. And then they should be able to basically identify or detect this abnormal behavior. So the unsupervised learning will be more suitable here. So the approach will be to tackle this kind of problem. The company might use algorithms like k-means clustering or autoencoders. So in k-means algorithm, this algorithm groups server traffic data into clusters based on similarities. So if a data point does not fit well into any cluster, then it is flagged as an anomaly. Similarly, in case of autoencoders, so this autoencoder is a neural network and it can learn to complex and reconstruct normal server traffic. So when it encounters an unfamiliar pattern, so then the reconstruction error will be more. So this will basically signal some kind of potential abnormal behavior. So using these approaches, what will be the now outcome? So outcome will be proactive threat detection. So the model identifies unusual activity and before it escalates into a major problem. So as the unsupervised learning does not rely on pre-labeled attack data, so it can adapt to new and emerging threats very quickly. So it will basically result in enhanced security of our resources, and it will minimize downtime, and the organization will be able to respond quickly. Now let's go through some of the advantages of unsupervised learning. Although these advantages we have already gone through. So it works with unlabeled data, so that is one advantage. So it has exploratory power. So because it can reveal insights or structures and data that might not be obvious, and it can be used as a pre-processing role where it helps prepare data for supervised learning tasks. So the unsupervised learning algorithm's ability to work with unlabeled data or to uncover hidden patterns or to prepare data for further analysis makes it an invaluable tool in the machine learning domain. So it is relevant across various domains and it has many applications. So these are the major advantages of this unsupervised learning, but it also has some of the limitations. The first limitation we can see is labeled as interpretability issues. So the results of unsupervised learning are often very hard to interpret. So in supervised learning, we have labeled outcomes to guide the understanding, but in unsupervised models, so it might produce clusters or components that require significant domain knowledge if we want to understand it. And ambiguity is another limitation. Because it is difficult to validate whether the patterns or the structures identify the model are meaningful or accurate. So for instance, a clustering algorithm might group data points, but without labels. So it is hard to confirm if these groups have some real world significance or not. Sensitivity to parameters is another limitation because in many unsupervised algorithms, so these algorithms are highly sensitive to parameters tuning. For example, in k-means clustering algorithm, so deciding the number of clusters can significantly impact the results. So choosing the wrong value may lead to the poorly defined clusters and misleading insights. So we can see that while unsupervised learning has many advantages, as it can explore unlabeled data, but understanding its limitation is again very important to apply it effectively. And we should be very careful while selecting a particular model. So the key differences, if we talk of key differences between supervised and unsupervised, so label availability is one of the key difference. In supervised learning, the dataset include label data. So this means data points come with an associated output or label. As we have considered the example of spam or ham email, but in the case of unsupervised learning, this works with the unlabeled data, so it does not have predefined outcomes. So instead, the model analyzes the data to find patterns or clusters or structures on its own. So the example of customer segmentation is a very good example to understand this working of the unsupervised learning algorithms. And again, applications are also basically differ significantly in case of supervised and unsupervised learning. Supervised learning is primarily used for tasks like classifications or regressions. So these applications basically involve predicting specific outcomes. For example, medical diagnostics we can consider. So a supervised model might classify whether a patient has a particular disease based on some input symptoms. But in case of unsupervised learning, so we talk of clustering and dimensionality reduction. So clustering groups data points based on their similarity, such as customer preference example, or dimensionality reduction using, say, this, PCA, principal component analysis. So these are the areas where these models are more applicable. Okay, now let's move to the third part, which is related to threat classification using supervised learning. So due to the paucity of time, so I will try to cover it in a fast speed. So if we want to talk of threat detection using supervised learning, so then these are the steps. So although most of the steps I have already described, so the first and the most important step is the collecting a labeled data set. So in the context of threat detection, so this means gathering data that includes both normal traffic and malicious traffic. So those should be clearly labeled what type of traffic is normal or labeled. Then the next step is feature engineering. So that means extracting meaningful features. So once the data is collected, the next step is identifying and extracting the most relevant attributes from the data set. For example, if we consider this a network traffic problem, so features like packet size, protocol type, connection duration, number of failed login attempts. So these can be some of the features. So the goal is to ensure these features provide necessary information for the model to differentiate between normal and malicious activity effectively. The next step is model training. So after the features are ready, so that then we need to train the model. So for threat classification, so there's number of models can be tried, like decision trees, neural networks, or random forests. So these algorithms can be used. So we need basically classification example. So a random forest model, for example, can be working very good for threat detection because it builds multiple decision trees and combines their output for predictions. And during trainings, the model learns the relationship between the features and the corresponding labels. And during this step, basically, model gains the ability to generalize and classify new and unseen data. And once the model is trained, then we need to check whether the model performs well. So we need to evaluate it using various metrics. So these metrics can be precision, like it measures how many of the detected threats are actually malicious. So this high precision means fewer false alarms. Recall can be another metric. So it assesses how many of the actual malicious threats were correctly identified by the model. So high recall minimizes missed threats. Then there can be F1 score. So this balances precision and recall into a single metric, providing a comprehensive view of the model's effectiveness. So such metrics help fine-tune the model and ensure that we have a model which is accurate and reliable in real-world applications. So basically, implementing supervised learning for threat detection involves systematically collecting and labeling data, then selecting meaningful features, training a model, and then evaluating its performance using metrics like precision and recall. And so by using these steps, we can develop systems that can proactively identify the real problems in our actual applications. Okay, now let's quickly see these two use cases.
Thank you, sir. Can we summarize at the earliest next expert has reached?
Okay, sir, just give me 2-3 minutes more. Can I take 2-3 minutes more?
Right, sir, sure.
Yeah. Okay, so let me show this anomaly detection using unsupervised learning, this particular part also. So this basically involves identifying data points that deviate significantly from the norm. So then basically in this we focuses on identifying data points which are not considered as normal or which are not expected. So then these are called outliers or anomalies. So then we can find this that these do not follow the usual pattern of data. So these are common environments with scarce label data. So anomaly detection algorithm advantage is that using supervised learning, it does not require labeled data, so it makes it suitable for many situations where labeled data sets are hard to obtain. And as I have described these techniques earlier, so using clustering or dimensionality reduction or using autoencoder neural networks, so we can easily develop our algorithms which will be able to basically detect these anomalies. And network data analysis, traffic analysis, and fraud detection in financial transactions are the typical use cases for this particular anomaly detection algorithm. So depending upon our application, so we can decide whether supervised or unsupervised learning is more suitable, or sometimes we can combine both approaches. So we can call it as semi-supervised learning approach. But there are certain challenges and then associated best practices. So challenges are related to the data quality and volume requirements. And another challenge is evolving threat landscape. So we have some suggested best practices to avoid these challenges, like data pre-processing, data labeling can be the best practices for data quality and volume requirements. Similarly, continuous model update can be best practice to evolve, meet the challenge of evolving threat landscape. So with this, I'm concluding this particular session by these three major points. That supervised learning excels in structured threat classifications, and unsupervised learning uncovers unseen anomalies in real time. So if we want to design effective algorithms, then we should be aware of the strengths and weaknesses of a particular model. Then we will be able to design effective algorithms. And sometimes we may combine the different algorithms to make hybrid approaches, which may be more effective than the single type. So thank you very much for the patience listening. So as Dr. Pankaj has announced that next expert is already there, so we can have, can we have 1 or 2 minutes for discussion, or as per Pankaj sir's permission? Thank you.
Yes, sir. You can respond to the queries.
Okay, if there is any quick query
The
or some.
queries, major ethical challenges arise using the data analytics for large-scale monitoring. And how have organizations addressed these ethical considerations in organizations?
Yeah, so basically, because this is another very important point, ethical issue. So I have not directly, not intentionally not touched this topic because this again requires basically one another session to cover this. So, but the ethical issues are very important. So, while collecting the data, so first thing is that when we are collecting some sensitive data, so the user, the individuals must be informed that data is collected and how that data is going to be used. So that is another important area that transparency should be there. So many times we see that the users, the individuals are not aware that their data is basically uh, uh, captured, or it is being utilized for the analysis. So such ethical issues need to be addressed in responsible systems. So
Right, sir. Sir, another participant has asked what are the best practices for labeling data in supervised learning to reduce bias and improve classification accuracy?
so that yeah, so that data accuracy is again a important issue. So while collecting the data, we should be aware that what are the important aspects we need to take in mind, because once we have data, then it is very challenging to basically refine the data. So while collecting the data, we should be aware of our requirements. So depending upon our application, our requirements, so we need to select the uh, desired algorithms or the techniques, so that we are getting the right kind of information which is reliable. And in supervised learning, we have that advantage of testing. So when we have trained our models, so we can test our models on some unseen known data. So that will tell us whether our model is effective or not.
Thank you so much, sir. Dear participants, as Dr. Saab has shared his contact details, so for further inquiries, you may drop the mail or contact him. So it is my pleasure to formally thank Dr. Balwinder Singh Dhaliwal from NITTTR, Chandigarh for delivering an exceptional and highly enlightening session on the topic supervised and unsupervised learning techniques for threat classification and